We are on page 115 of our book. We're going to be working on the exercises for Chapter 2. We're going to start with number 4, which is the first one that's assigned. All right, so let's take a quick look at what the problem says. And even though it seems a little cumbersome, I'm going to read it out loud. And sometimes just simply in the reading of it, the solution will pop into your head. Usually some of these will have some sort of a logic thing involved with them, or some sort of math or sequence, or a specific series of steps that you want to follow in order to make sure that it works. So let's proceed. It says 4A, write a Java class that declares a named constant to hold the number of quarts in a gallon. 4. So it's telling you, create a constant, its value is going to be 4. All right, so that's one thing we're going to do. Also declare a variable to represent the number of quarts needed for a painting job and assign an appropriate value. For example, 18. All right, compute and display the number of gallons and quarts needed for the job. Well, they're just giving us quarts. Now, all of a sudden they want gallons. How many quarts in a gallon? 4. Nobody knows that anymore. How many pints in a beer? Well, there you go. That one everybody knows. All right. Display explanatory text with the values. For example, a job that needs 18 quarts requires 4 gallons plus 2 quarts. So they want verbose output. Okay? And then save it as follows, quarts to gallons. So the first thing that we're going to do is we're going to come over to Eclipse, since that's the tool that we're working with today. And in the previous video we were working on this Hello Racine project, but I'm going to go ahead and create a new Java project, and I'm going to call it quarts to gallons. And then I'm just going to click Finish. You can see it created the root of the project. Now that the project has been created, I am going to expand it. I'm going to right-click on the source folder and then do New Class. All right. Right-click on the source folder, New Class. All right. We are going to call it quarts to gallons, and this is the actual name that goes on the class file. We're going to choose this little checkbox here that says public static void main, so we don't have to create it ourselves. And then we're going to click Finish. Please ignore the errors down here for right now. They're pretty much irrelevant. If you want to clear them, I guess you can do that. That was from our previous work. You do not need to leave the comments in here. One thing you might want to consider doing with your work, though, and I have some people that are in the habit of it and some that aren't, is you can put comments at the top of your document. Put their name up there, exercise, whatever, just if you want. I think it's a good idea that as you code that you use verbose comments, especially when you start to do more complicated things. For some of the rudimentary work, perhaps not, but I'll let you be the judge of that. So we have very specific instructions here, and the first instruction was declare a named constant to hold the number of quarts. So the way we're going to do that is we're going to create a final, that's how we declare constant, remember that? And how, number of quarts, integer, double, what do you guys think? Integer. So we'll do int. And why don't we call it, yeah, that's a good one, quarts. Why am I having such a hard time typing today? Because I've been at it since the wee hours. Quarts in gallons. Yeah, it kind of is. You don't have to name it that way. I'm just, all right, so how many quarts in a gallon? 4. And why are we doing that? Because the book said, right there, number of quarts in a gallon, 4. We're just following what they're telling us. All right. Also declare a variable to represent the number of quarts needed for a painting job and assign an appropriate value, for example, 18. So really what we're doing is we're hard coding something instead of being able to input it. Understanding? We're just getting it to work, brute force getting it to work. So we're going to create an int then on the next line, and we're going to call it, here I am in all caps, not where I want to be. And let's call it quarts needed. And they told us to set it to what? 18. The one thing I want to point out to you, are you guys noticing the subtle yellow underlines here? That's not an indication of a problem, because if you hover, you'll notice what it says. The value of the local variable quarts in gallon is not used. Well, of course not. I haven't used it yet. I just declared it, right? But what that's helpful for is if you get the program and you're all done, then you go back and you look at a variable and it's underlined in yellow, like, well, I can get rid of this, right? So that's why it's there. Because to make a program run efficiently, you should get rid of all the stuff you don't need inside of it. Okay, let's move on to the next step here. All right, so we completed basically the first 2 sentences. Compute and display the number of gallons and quarts needed for the job. Now we got a little bit of math to do, right? Do you guys think that we need any additional variables? And if so, why?
This is actually something I was curious about. You need 2 more total answers, right?
Potentially. That's where my brain goes to.
The example given is we're not being they want the remainder, you know, like an analysis stated, you would need something set over that, right?
Exactly. Do you guys catch his rationale? So they're looking for information, and the clue is in the answer here. It says, a job that needs 18 quarts. Where are we getting the 18 from? We hard-coded that, right? Requires 4 gallons. Where are we getting 4 gallons from? Did we set something up? No, we put quarts needed. Might we want to include gallons needed? Okay, let's do that. Let's go int gallons needed. How are we going to figure out how many gallons we need? Well, I could do a calculation right there. But for right now, I'm actually just going to declare it and walk away. Okay? Because really, we don't know what that's going to be at this point. Because what if that 18 quarts is something different? All right. The other thing that you might want to think about, and that's what Jay was just talking about, and that is that they also want the remainder. So we know that there's 4 quarts in a gallon, right? So if we say 18 quarts, how many gallons is that? 4. How many quarts do we have left over? 2. So we need a spot to put the 2. So let's create another int and call it, I don't know, extra quarts. Doesn't really matter, you know, technically what you call it, as long as it makes sense to you. Okay, so we've set up our variables. Now let's go ahead and do some logic. Now, the 2 integers that we declared, the gallons needed and the extra quarts, those are not predetermined values. So we have to do the math to figure it out. So we already kind of did the math, right? So can we say gallons needed equals express it for me. How do we figure it out before? Could it be the number of quarts that we have divided by what? Quarts in a gallon. And notice this is where we're using our constant. And then notice as I finish off my statements, put the semicolon in, how everything corrects, all the underlines go away. So as you're in progress of typing out a statement, don't freak out to the underlining, because it will, yeah. Panic! Okay. No, don't ever panic. All right, so that's the first calculation. That'll give us the number of gallons needed. So that'll give us the 4 gallons we need to display. So we also need to know the number of quarts that are left over. So let's calculate for extra quarts. And what's that going to be equal to? This is where the math gets fun.
2.
Okay. Thank you, voice from cyberspace. Yes, it will be 2. But sincerely, the question is now, how do we get to that number?
I would use the mod function.
Aha! Did you hear the voice from cyberspace? From here on in, known as Sean? Yes, the mod function. Operator, actually, not a function. So we're actually going to, what are we going to mod?
The entire value. So it's going to be 18 mod 4. Or
18 mod 4. We can use the variable names. Why would? Because it's more adjustable, right? If we use the variable
Yeah.
names. But what math are we doing?
We're finding a remainder.
Yeah, we're finding the remainder of what?
Quarts.
Can we just take this? Here we figured out how many whole numbers come out. Right, and this is part of that whole casting of data types going on here too. Because really, if I pull up a calculator and type in 18 divide by 4, right? It's 4.5. So that's what's being stored here, right?
Indeed.
You should get only 4. And why is that? Because it's an integer, it does integer division. If I wanted it to calculate to a decimal, then I have to declare a double. But we want to know how many gallons and how many quarts. I don't care if it's 4.5 gallons.
Actually, we use doubles. Mine was kind of weird for this.
If you figure out how many, if you use the mod and you figure out how many quarts are left, you're gonna get, the remainder is 5.
Nope. Nope. What'll happen here is we're basically dividing. So quarts into gallons goes in here 4 times. That's 16. How much is left over? 2.
2. Perfect.
Right? Yeah, it makes sense, doesn't it? I know it's a little weird. The percent sign is for mod. Really, all that's left to do at this point is to give the user some useful message. And really the best thing to do is just to kind of copy what they have here. A job that needs let's see, 18 quarts. Quarts requires and now we're going to display the gallons that we calculated, and that's going to be stored in gallons needed. Gallons plus. Note that I'm also leaving spaces so that the numbers don't touch the words. You got a code done, and you guys should know that already, I'm hoping. And we need that 2, and that's going to be extra quarts. Quarts. Period. So a job that needs quarts needed, which is 18 quarts, requires gallons needed, which calculates to 4 gallons plus extra quarts, which calculates to 2 quarts. Right? We're good? What do you guys think?
That should give us the outcome we want.
The percent sign, it's basically, it's remainder division. So you divide, but you're not looking for how many times it goes in. You're looking for what is left over. No, because there's times when you want to know what's left over. The classic example really is making change.
So all it gives you is what's left over.
Just the remainder.
Okay. I was confused by that.
Yeah, and it doesn't seem like that would be something useful, but when you're doing computer programming, you're accounting for certain things, you have stuff left over, and you're like, what do I do with it? You need to know what that is before you can do something with it. Because certainly, I mean, we could divide the 4 into the 18, realize it's 16, then subtract the 16 from the 18 and still come up with a 2, right? And that would be actually a valid solution. If you did it that way, and you turned it in, I'll give you credit for it, because it comes up with the right answer.
I used levels to get the remainder, and then took the remainder. Well, okay, I pretty much used the same formula twice to generate the same number, and then subtracted I used the 4 on one of them,
Okay.
and then subtracted the original value from the second to get the leftover, and multiplied it back.
You guys catching all this?
I did a whole math
Right.
thing redundant, you know.
Or-
saying subtract, I was like, take away, like way more work, you know.
Yeah. But, you know, it shows that you're going through a different thought process, and there's nothing wrong with that. But then you see the other way to do it, which is like really straightforward and clean.
For sure,
Yeah. And not that your way wouldn't work. I mean, I could probably code maybe a dozen different ways to come to the same answer. But generally speaking, the most direct route to the answer is the best one. And this is really the best approach because it's built for the leftover. That's the mod. All right, shall we run it? You already did. A job that needs 18 quarts requires 4 gallons plus 2 quarts, and that's what we were targeting, right? Yay, one down, part B to go. All right, so part B says, convert the quarts to gallon class to an interactive application. Instead of assigning a value to the number of quarts, accept a value from the user as input. And so we're going to revise this and save it as quarts to gallons interactive. All right. So what I'm going to do here is I'm going to right click on the source folder again. See, I'm right up here. We're going to do a new class, and I am going to call it quarts to gallons interactive. Now, this author will do this often. And really, it's kind of a twofold thing. It's like, why don't we just go right to doing this? The reason is very simple. When you're coding, one of your best problem-solving techniques is to just brute force make something work. Make sure your logic's right. Then it can add all the glitz and interfaces and interactivity you want. But if your math's not working underneath, I don't care how good it looks, it doesn't really matter. You know, you got to be able to make it go. And I'm going to fix that capital N there. And a public static void main, and we'll say finish. And then why reinvent the wheel, right? We already did all the work here. So I'm going to come in here and I'm just going to grab all the code that sits in between and go over to the new file and paste it in. So majority of it's done. The thing that we don't have done is this piece, because we're still going to declare it, right? But watch what I'm going to do here. I'm going to pick this up and click, drag, drop to this location here, because I'm going to populate that kind of as we go, making a little bit of space. And do you guys remember how we get input from the keyboard? Somebody say it.
Need a scanner.
Scanner. Thank you very much. Now, remember when you're writing it in a primitive text editor that you have to do your import statement? You're going to love this. Watch this. As you hear the hallway people walk by. So I'm typing scanner. I'll just call it input. You can call it whatever you want. Doesn't matter. Then I'm going to say new scanner. And what do I put into parentheses? System.in. And we'll put our semicolon at the end. Now, it doesn't like the fact that I didn't do the import. You guys see that? If I hover, notice what it says. It says scanner cannot be resolved to a type. Hey, look at this. Import scanner Java utility. Let's see what that does. It puts it right up the top for you. Isn't that cool? You guys catch how I did that? It's underlining. I hovered. Now notice the other thing that it can do, it's got more than one fix. There's a bunch of different possible fixes. You also kind of have to know which one you want. That's kind of the catch with it. We know from our experience that this is the one that we want. So adds it in for us, really kind of takes out of the mix the possibility of importing the wrong thing. All right. Also saves you the hassle of looking it up. Now we're going to be declaring this variable actually below the scanner. And see, quartz needed is where we're going to store it, right? So talk me through the process of doing the scanner here. So what am I going to do? Input. This is how I know you guys did the homework. Is this right? How do I get input from input dot next int? And notice what I'm doing is I'm declaring the variable and I'm grabbing the input from the keyboard and storing it in there all in one fell swoop. Right? I like that approach, very efficient. Now I got a bunch of additional space here. Is there anything else I need to do? Oh, we need to prompt. Yeah, we need to prompt the user for some input. You don't just like say, "Give me a number." Well, no, you have to say, "Give me a number." That's the whole point. They don't just know to type something. All right. So we need to do a prompt, right? We can do the prompt. We can do it above the scanner, below the scanner. It doesn't really matter. But it should go above this particular statement. So the way we're going to do that is we're just going to output to the console system.
.out.print.
Print, thank you, not print line, because then that will leave us on the same line waiting for the prompt. Thank you, voice from the internet named Sean.
And then we need the parentheses, quotations, and then please enter the number of quarts needed. Then a space and greater sign.
There you go. Does that look good?
Yep.
It's good to me. Let's go ahead and save it. Run it. Sure. Please enter the number of quarts needed. Let's try 18 since we know what the answer for that one is. Seem reasonable? Smart choice. Test it with a value that you know. And it came out with the same thing that we saw before, right? 4 gallons and 2 quarts. So let's try a different number. Let's do, I don't know, 24. How many is going to come back?
Do 26 so we get the same thing where we've got to have leftover.
Working for everybody? All right, so that's exercise 4A and 4B. Quick pause here, folks. All right, so those are exercises 4A and B complete. Now we're going to move on. I think number 5 is next. Is that correct? All right, and this one says, write a Java class that declares named constants to represent the number of kilometers and miles in a nautical mile. So what kind of variables will we need for that? Obviously not integers, right? We'll use doubles for those. Also declare a variable to represent a number of nautical miles and assign a value to it. Compute and display with explanatory text the value in kilometers and miles. So if you look ahead to part B, we're kind of following the same pattern. We're going to set it up, get it to work. We're going to hard code a value just to make sure it works. And then we're going to go through and make it interactive and pull in a value from the keyboard. So we kind of have a model for how we're going to proceed. So we're just making really kind of a slight adjustment to our path. So we're going to call this nautical miles. So we're going to come up here, do a new project. And I should indicate, for example, okay, I'm naming the project what the name of the class file is, but you don't need to do that. So you might actually choose to do chapter 2, exercise 5. Because that's what the folder name will be. So that might be, I should probably point that out. So I'm going to click finish. And then I'm going to come in here, I'm going to make a new class file inside of it. And here's where I'm going to do nautical miles. Create a main method. Please holler if I'm going too fast. I'm all fueled up on coffee all day, so. Then listening to speed metal on the way here doesn't help either, right?
Who are you listening to?
Oh, do you really want to know?
Yeah.
Should I pause? I don't want to scare away my students. All right, so now we have the basic structure of our program here, and let's follow the instructions, which once again were name constants to represent the number of kilometers. So we're going to do final. What do we say? Doubles? Double. And I'm going to do num of, I'm going to abbreviate, num of km. And can somebody read to me the value? 1.852. And then we're going to do the same thing. And we're just going to go MI for miles. And this one is 1.150779. Is that right? Yes, it is. All right, so we have our two finals in there. Also declare a variable to represent the number of nautical miles and assign a value to it. So what data format? Double? Yeah, let's stick with double. Double. And we'll just say nautical miles. And they want us to assign a value. How about 150 nautical miles. I'm just picking a number. Actually, you know what? It's a good number to pick? Something that's really, really easy to calculate. Right? Because if we do multiplication or division, this is going to be cleaner, basically. So let's do that. All right, so we got that part done. Now we need to do the math. Now, you guys are probably taught in Intro to Programming, I hope, that you should solve the problem first and then code it. And what are we doing? Yeah, we're coding it and then solving it. All right. But I do have firmly in my head that we need to do the math. When it's with a simple program like this where you're kind of given the steps, it's okay. But when we get towards the end of the program and I give you your final programming project, there's no way you can jump into the code and figure it out. Straight up. You will. Yeah, the egg one, yeah, that one's kind of fun, actually. All right, so what's the math? The number of kilometers in a mile and the number of miles in a nautical mile. What's the math?
Multiply.
Multiply. So I just multiply those and I'm good? Do you guys agree?
Yep, for each though.
Okay. Do I need any additional variables?
You could create one for each output. So for example, you could create miles and then kilometers.
Okay, I like that idea. I want you guys to think about it a little bit. There's certainly a number of different approaches that you can take. I mean, really, what Sean suggested is correct. The calculation really is a straight-up multiplication. There's nothing really convoluted about it. If you're sitting there and you're thinking kind of a little beyond that, maybe you're thinking a little too hard, right? So really what we need to figure out is really the number of kilometers. We also need to figure out the number of miles. And that one I'll just type out. So I'm setting up variables to hold the values. All right. Next thing we're going to do is we're actually going to do the math. So in this case, I'm going to say kilometers. How do we do that? Okay. Nautical miles. We said it's multiplication, right? What am I multiplying against?
Num of my.
Right?
Oh, KM, you're right. Sorry about that.
We'll forgive you this time. Next time, no go. Now, as we're kind of doing this work here, and I know there's people that are going to be at home listening to the videos, or at least I hope so my time's not wasted. You can do what Sean's doing if you guys ever want to hang out with the class. I sometimes put out invites and people don't take up on it, but at any point in time, you can either hang out with us, or we can use Google or Blackboard Collaborate, or got a bunch of different tools we can use. So that's our math. We agree? Is that good?
Looks good.
And then we just want to do our system out. All right, so what do you want to say?
Nautical miles, space plus sign, and then quotation space plus, and then however you want to put it.
Okay.
So like nautical miles is equal to.
Okay, so, you see where Sean's going. Sean, you've obviously worked on this already, right?
Yeah.
Okay. So he's working from a solution. He's not pulling it off the top of his head. What I might actually suggest is I might start with actually listing the number of nautical miles, right? Which is going to be a number, and I'm going to say like 100 nautical miles. And then what? Maybe say equals what?
We're doing KM?
And actually what I'm going to do is I'm going to bump down to the next line here. Oops. And what do you think? Worst case scenario is we mess it up. Do it again. I'm going to go ahead and save this. I'm going to run it. What should be the answer? Well, don't guess. $185.2. Yeah. Okay. You guys get it. So, but okay. You guys are running into an issue there that's kind of interesting. So we'll talk about that in a second. Right, let's actually go ahead, save it, and run it, and see what it does. 100 nautical miles equals, right, because you would anticipate that it would be really pretty precise, right? It would stop at 0.2. Yeah, but actually how precise is it if it's doing that? It's adding a 0.00000002. It really is indicating that we're kind of pushing the bounds of the data type. All right. You can use some of the formatting techniques that you find at the end of the book in the appendixes to truncate that down. If you get this, it's fine. Okay? It really is okay. It's really that the calculations are working that's important to me. Okay? All right, so if we're going to turn this into something interactive, once again, we're going to be asking for this piece of information, right? So once again, what I'm going to do is I'm going to leave my variable declarations at the top here. And I'm going to insert my scanner right in this spot. So I'm going to follow the same technique. I'm just going to say scanner. Oh, you know what? Yeah. Yeah, I'm getting kind of bold here and being silly. Joan, you should get like an extra point for the day for catching me before I totally... So I'm going to add another class file. And what do they want us to call it? Nautical Miles
Interactive.
I'm guessing. You know what? That happens. So I'm going to grab all the code in between here. And then we're going to do the whole part that I was trying to do here. No, actually, I'm glad you made me stop. I'm leading myself blindly down a path I don't want to go. We're going to put their scanner in. And over time, you will get to memorize a lot of this stuff. It really doesn't take much. You just basically do a couple of homework assignments and you're kind of memorizing it. So, and then we're going to do our prompt.
Need a second greater than sign.
Why?
You know, that's a good question. Is it required or is it just for emphasis?
Oh, it's just a preference.
Interesting.
I could just do this. See, nobody saw that, right? Am I good? Nod and smile.
Int next double. Yep.
All right. We're running it. It says enter number of nautical miles. Let's try the number that we already know. Get the same response. Let's go ahead and run it again. And let's put in some decimal number this time. Okay, and that is exercises 5A and B. All right. With that, I'm going to terminate the video here. That's not my video. And we'll see you in the next video.